In this lesson, we're covering tangent lines of circles, part 1. So part 1, we're covering determining if a line is tangent to a circle and determining the side length of a right triangle that includes tangent lines. So let's get started. A tangent line intersects a circle at exactly one point called the point of tangency. So here we could see that line L is our tangent line right here. And point T would be our point of tangency. I'm just going to call it POT. So point T is our point of tangency. And a tangent line is also perpendicular to a radius that is drawn to the point of tangency. So this is the radius right here. You can call this R. And it is perpendicular to the radius. So our tangent line is here, line L. And as you can see, we have this right angle here. I'm going to circle it in red. So a tangent line is perpendicular to the point of tangency that touches the radius. And for our first example here, it says determine if AB is tangent to circle P. And the way we determine that is looking at the triangle here. We just want to see if this is a right triangle, because we know a right triangle has a right angle, and that will make this point here our point of tangency, and that will make that a right angle, and so that will make AB perpendicular to this line right here, or perpendicular to the radius. And so to determine that, we use the Pythagorean Theorem. Remember, the Pythagorean Theorem is a squared plus b squared equals c squared, and we use that to find the side lengths of right triangles as well as to determine if a triangle is a right triangle. So remember, A and B are our legs. So in this case, our legs would be 8 and 15, and our hypotenuse would be 17, which would be C. So remember, the hypotenuse is always opposite the right angle, and we're just trying to see if this is a right triangle. So the line that goes from the center, like out here, so this line here, this would be the hypotenuse because we're considering it opposite the right angle, and A and B would be our legs. So let's plug it in, and we're going to see if it makes a true statement, and then that will determine if this is a tangent line. So 8 squared plus 15 squared equals 17 squared. There should be an 8 here. So that would be 64 plus 225 is equal to 289. 64 plus 25 is 289. And this actually checks out. So we can say yes, AB is tangent to circle P. And I would like for you to try this next example here. So go ahead and just pause the video and try this problem on your own. See if AB is tangent to circle P. So go ahead and pause the video. Okay, hopefully you got it correct. AB is not tangent to circle P. So I'm going to say to circle P. When we plug into the Pythagorean Theorem, we do not get a true statement. And there was an added piece that you had to determine here. So that 5 only covers from here to here. So from P, point P to the edge, that would be 11, because that would be another radius. So hopefully you saw that. If not, that is where I got the 16 from, right here. Okay, because that 11 right here is the radius. So I added 11 plus 5 to get 16, which would be the hypotenuse, or maybe our hypotenuse, and plugged it into the Pythagorean Theorem. So if you didn't get it right, pause the video and just check my work here a little more. So let's take a look at these two examples. It says if JK is tangent to circle L, find X. And so again, we're going to use the Pythagorean Theorem, a squared plus b squared equals c squared. And I'm going to draw this right angle here because that will make a perpendicular line there. And so I'm just going to plug it in. So 7 would be A or B, one of my legs. B would be 19, and C would be our hypotenuse or our x. Again, because that is opposite the right angle. So I'm just going to plug it into the Pythagorean theorem. That is 7 squared plus 19 squared. And remember, A and B are interchangeable. I could have put 19 squared plus 7 squared. Doesn't matter. And I could either put C squared or X squared. I'm going to put X squared since that is what I am looking for here. Alright, 7 squared is 49 plus 19 squared. Let me see, what is 19 squared? That is 361. Adding that together, we get 410. Then, of course, to get rid of that x squared, square root of 410 is 20.2. So x would be 20.2. Let's take a look at the next one here. A little differently, or a little different. If you notice, this piece is just x, but I have another piece here of 10 because that would be a radius. So I'm going to call this whole segment here y. Okay, that is x, so only from K to the edge of the circle. I'll draw it in red so you can see it. So from point K to the edge of the circle, that is just x, the unknown. And then from x, or the edge of the circle, to the center, it would be 10 because that would be a radius. All right, so now I'm going to use the Pythagorean theorem again. This would be the right angle here. Our point of tangency is J. Plug it in to the Pythagorean theorem, A, B, and then this would be our hypotenuse or our C. So plugging that in, 10 squared plus 24 squared is equal to, so we can call this y squared. So simplifying, we get 100 plus, so 24 squared, 576 is equal to y squared. Adding them, I get 676 is equal to y squared. Then I want to take the square root. Square root of 676 is 26. That is a perfect square. So we still have not found x. So y is the whole piece over here, right? And so what we can do, because we know that this length here is 10, the only thing we have to do is subtract 10 from, and this should be 26. I don't know if I said 26 and wrote 25, but this should be 26. So if the whole length here of y is 26, then that would make this piece here 16. If you want to set up an equation, you can say x plus 10 is equal to 16, 26, and then I get 16. Alright, so either way you're going to get 16. So x is 16 for example 4, and x is 20.2 for example 3. So this is the last problem, example 5, that I'm going to do with you. The last one, or the example 6, I want you to try it on your own. It will be very similar to this problem. This one is a little different. You're going to have to use some of your algebra skills and remember how to solve or to multiply binomials. So let's go ahead and just try this one. So our radius is x, all right? So this piece here will also be x, all right? And then, so from here to here, this would be x plus 10. And I'm not going to call it y because I have another x right here. And so since I have essentially two x's, I don't want an x and a y in the equation. So I'm going to set it up, still using the Pythagorean theorem. A squared plus b squared equals c squared. All right. So our a would be x. So I'm going to say x squared because that's one of our legs. We don't know what that is, so it's x squared. B would be 20, so plus 20 squared is equal to c squared, and so c would be our hypotenuse. So if you notice here, that is our hypotenuse. That would be x plus 10 squared. And so that is why I did not call that point or this segment y, because we would have had two different letters in this equation. And so now simplifying, x squared plus 20 squared, that's going to be 400. But a binomial squared, remember, you have to either use the FOIL method or the distributive property to multiply it through. So I'm going to just do some work here on the left-hand side. I'm going to write x plus 10 twice because I have to use the distributive property to multiply that through. So x plus 10 squared, we have to multiply it times itself. If you think about it, if you think about a number maybe like 3 squared, you multiply 3 times 3. So that is why we're multiplying x plus 10 times itself. So we have to write it twice there. So I'm going to use the distributive property. So x times x is x squared. X times 10 is 10x. 10 times x is 10x. And 10 times 10 is 100. Simplifying or combining my like terms, 10x and 10x, that will give me 20x plus 10 right here. So now I'm going to go back and just plug this piece here into our equation. So that would be x squared plus 20x plus 100. Now I'm going to solve for x. I have x squared on both sides. So just doing inverse operations, this is a positive x squared right here. So I'm going to subtract x squared from both sides, combining it with the like term, right? Because I can only combine it with the x squared because it is a like term. But what do you notice? What happens to our x squared? It cancels out because x squared minus x squared is just 0. I'm going to bring down my 400, and x squared minus x squared is 0. We cancel that out. So what is left is a two-step equation, 20x plus 100. Alright, so I'm just going to solve this two-step equation here. Subtract 100 and get 300 equals 20x. One-step equation now. Divide by 20x. So we're going from a multiplying binomials to a two-step equation. And 300 divided by 20 is 15. And so we have found x using the Pythagorean Theorem and using a bit of our knowledge for multiplying binomials. So the next problem, you know, I'm going to ask you to try it on your own. Alright, so our last problem here, it says a segment is tangent to the circle below. Find the value of x. Hopefully you wrote down some notes. This is very similar to the problem I just did, so go ahead and pause the video and try this problem on your own. Alright, so you should have gotten x equals 9. Hopefully you got it correct. If not, pause the video and analyze my work here a little more. Alright, we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are tangent lines part 2 that will analyze a few more properties with tangent lines. And then we have arc lengths of circles. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.